Dr. Raymond Hayes, underwater archaeologist, made a major discovery in his investigation of shipwrecks. He found a quick, non-destructive method to analyze them, handheld XRF. He can now study specimens where he finds them, in museums and even when they are moving on platforms offshore. He no longer has to remove a piece from the wreck and send it off to a lab for analysis. He can simply analyze artifacts on the spot without harming them. Dr. Hayes analyzes wooden shipbuilding materials including oakum, Irish felt, pine tar, caulking cotton, copper sheathing, tree nails, and metal fasteners. He studies raw lumber, ship timbers, and various wood treatments for comparative baseline data. Shipwrecks he studied include the Charles W. Morgan, the CSS Alabama, and the USS Housatonic. Dr. Hayes recently had the opportunity to study the sparrowhawk, which is housed at the Cape Cod Maritime Museum in Hyannis, Massachusetts. The sparrowhawk, carrying English settlers headed for Jamestown, Virginia, ran aground near Plymouth in 1626. It was discovered after a storm in 1863 and exhibited on Boston Common in 1865. Dr. Hayes used an Olympus Innovex DELTA Standard handheld XRF analyzer. This handheld XRF couples a high-resolution, large-area silicon drift detector with a powerful 4-watt tube to deliver fast and precise compositional analysis of a variety of materials, including metals, alloys, soil, sediment, wood treatments, and fluids. With dramatically reduced testing times, the DELTA allows hundreds of tests per day, enabling immediate, in-the-field decisions, optimizing any research and discovery budget. The XRF analysis indicated that the wood absorbed elements from materials it came into contact with over the years. Iron could be from original posts and fasteners, while chlorine is likely from the salt of the ocean. Elements such as sulfur and calcium may be remnants from sea life attached to the wood over time. Silicon simply could be from sand. Dr. Hayes maps out his analysis objectives for the shipwreck prior to taking measurements. He creates a schematic of the wreck and maps off areas of analytical interest. He then places a measuring tape along the specimen to provide precise analysis locations. He uses a delta soil foot and a piece of board to keep the analyzer steady on curved pieces during analysis. It is unlikely that any metal from the sparrowhawk would have survived over time simply because of scavenging. However, the metal post found in the stern and the metal fasteners found where the rudder would have been attached did have different compositions. The post may have been inserted in the 1860s when the sparrowhawk was brought from Cape Cod to be exhibited on Boston Common, while the fasteners may have been attached around 1890 when it was transported back to Plymouth.